and Sophie and Paolo and Stefano, who unfortunately left, for all the work behind to the preparation and the organization of the scientific committee and all the ideas, the funding, the proposal, and everything. So thank you, everybody. And yes, we start with the reports from the breakout sessions. Yeah, and a big thank to Simone and Maurizio from from our Regia, who have been really helpful in these days. So we start with the first breakout session topic, and I leave the floor to our speakers, Valentina Raimondi, Shungo Garaba, Manuel Arias, and Constantino Sopuzelis. And yes, I mean, I am just here to change slides if you need.
Thank you very much, Silvia, for this nice introduction. I'll start with breakout session number 2 about technological requirements. First of all, I would really thank the organizers for these breakout sessions, because they were the occasion to discuss between also people that have different backgrounds. Our breakout session had the chance, I'd say the lucky situation, to have also some participants coming from other breakout session, delivering their contribution as modelists, for example, as people doing sampling and so on. So it was a very alive exchange of information, really fruitful. So let's have a look to the breakout session title, Technology Requirements for Effective Space-Based Measurements to Identify, Characterize, Quantify, and Track Marine Litter and Potential Extensions to Other Floating Matter. So what I want to underline is that one of the first statements we discussed within the group the very first day was about the state of the art. Most of the people attending have already taken part in previous sessions at European Space Agency workshop on marine litter, for example. And well, the first statement was the difficulty in addressing plastics, plastic litter rather than floating matter. This was indeed the very first objective that was set at the beginning of the meetings held in 2016 in ISA. But indeed, after several years, there have been a lot of effort, nice results and so on, but detecting plastic litter is still a big challenge from satellite-based instrumentation. I want to underline that we addressed satellite remote sensing. So we started considering technological requirements, but of course we had to take into the due account the scenario we were addressing. Several scenarios were already identified in the scientific community. And as usually people dealing with technological development of satellite-based instrumentation, we started our discussion about the major key requirements for an optical or in any case satellite-based sensor that is spatial resolution versus spectral resolution and signal to noise ratio. Of course, we considered which is the state of the art that has already been described by the community in several papers already published. So for a discussion about spatial resolution requirements and spectral requirements, we can refer to these papers. But our focus was on the fact that based on the results obtained up to now, maybe a limited set of few narrow spectral channels in the short wavelength infrared could be beneficial to better address plastic litter. One of the major challenges it was outlined, pointed out also during this workshop is to identify plastics against other types of litter. What we did next, it is not. What we did next was to identify some possible product scenario and products. Thanks to the suggestions by Victor, we prioritize them, we're ranking them on the basis of four main parameters that have been already identified of major interest in scientific publication. It is reported in the upper right corner, Skidmore et al., published in Nature, Ecology and Evolution. So the scenarios that are rather products that we identified started from what was already chosen our primary products and scenario in the meeting led by Victor during the workshop on marine litter held the European Space Agency ESTEC headquarters. Well, first of all, we analyzed the plastics on beaches. Well, this was, in our opinion, one product that is can be considered achievable in the most quicker way, somehow easily achievable. Then we considered floating plastics in accumulation zones, for example, windrows in marine environment, and this is still a very challenging scenario products. Then we address floating matter. This means anthropogenic and natural floating debris in marine environment in accumulation zones. And finally, floating matter in rivers. Of course, I underline again that satellite, this refers to satellite remote sensing. We focus just on what can be provided by means of satellite sensors. So the rate was quite a simple one, from 1 to 3, when 1 indicates the highest score, that means a high maturity level, for example, for the first criterion, and 3 is the lowest. I'll ask to Victor to introduce further the nice game that he has prepared together with all our companions.
Okay. Okay. So what we did was to spend this morning, a lot of the part of this morning, filling in this table for the different, for at least 1, 2, 3, with the 4 scenarios there. So there is the next slide that has our scores. So we wanted to have a validation of our scores by the audience, right? To see how much we're closer to what the public is, or the audience, the wider audience is aligned. I don't think that we have time to go through all of the 4 scenarios and public, because I have to explain now what each of the criteria means, right? So my suggestion, if this is okay with you, and we can, it's that we, by a show of hands, say which one of the products we would like to rank or to give it some scores in terms of that. And we can maybe deploy then this questionnaire wider offline or something. Does it sound like a good idea? So not to spend a lot of time on this. This is just a game, yes? So, okay, and this is a bit tricky because we're talking about a scenario, which is beaches, for instance, and plastics. So we're thinking about plastic on beaches, detection of a plastic in a beach in the middle of a mixture of other things that may be on the beach. Okay, so I go through each one of them, and then we can do a show of hands who prefers, for instance, for the first one, how many people would want to rate the maturity and relevance and feasibility of the plastic on beaches? So of these people, who would like to, they can raise their hands. I mean, one person can vote several times, but ideally we have, okay. Okay, so 1 or 2 or 3. Okay, the second and the third are very similar, but carefully read. One is the detection of the plastics within a mixture of floating material, and the other one is the detection of any floating material in accumulations, right? So I go to the fourth. Floating, floating matter on rivers. Who would like us to focus on? I go with the easier ones. Who would like us to focus on remote sensing from satellite on rivers? 1, 2, 3, 4, 5. Okay, a little bit more interest than in the first one. Okay, now, accumulation of total floating matter. Who would like that we focus on evaluating the maturity, relevance, and feasibility of the accumulation zones on fronts or windrows, or however you want to call it. So please raise your hands if you would like us to discuss this and provide some estimates, some points on this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay. And the final is, who would like us to focus on a discussion or on the evaluation of detecting the plastics within a mixture of other things? A ver, no, you have to be, no, you cannot be in the middle, like here or there. Clearly up, because half a point doesn't count. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we're gonna rate the floating plastic sort of detection within accumulation areas, within a matrix of other stuff, right? We're all agreeing on that. Okay. So I'm gonna need to. I will switch to the Mentimeter so that people can start preparing for the Mentimeter while I explain the criteria. Let's see if you can multitask. I cannot multitask, but I'm hoping that you are more capable. So, who's switching screens? Switching screens. Yeah, mine is off.
Because the very first step was to understand the criteria, I mean, explained in the paper so that we discussed a lot. For example, maturity, I immediately thought it was TRL because we are very familiar with it.
But
it
maturity is
was
not. Okay, I have copied the things. Okay, so you have there, now it is showing, right? I cannot see. So there you have a Mentimeter. I don't know if you're familiar with it. Just either a QR code or go to menti.com and then insert the code there. I don't know if you're. I can move the code. It's not very good. Huh? Okay. I have 15 people logged in. I'll wait until we get to 18 or to, you're starting voting. Hey, you don't know what you're voting. Who's the, don't vote. I haven't explained. Don't, quick, you're quick on the click, but no. I mean, we have one less point. Okay, wait. Just make sure that you log in, but don't answer the questions because you don't know what you're answering. I mean, anyway, plus minus one to our result. Okay. Anyway, these people are keen. Okay, so I have 20, so I'm going to start explaining this. I assume everybody has. So the first question is about maturity. And I don't know if you see the questionnaire there, where you can switch and put as a first option your choice of one. Giving a score of 1 means that you move the 1 to the first position. And this is about how operationally implemented the detection of floating plastic litter is at the moment, okay? And you can give it a 1 if it is really good, if we already have a floating plastic litter detection algorithm implemented in Copernicus, which is the Copernicus Marine Services, or a 3 if you give it a complete lack of, you're starting voting, this is quick. Complete lack of relevant infrastructure or relevant and things that could be implemented operational within the next decade. If you think that there would be if you think that it could be even longer than a decade, put a 3 because there is no more than 3 values. But if you think that in a positive mind frame, we would see an operational detection of floating marine plastic litter detection within 10 years, you give it a 3. If you think that it is already there, that we already have it in Copernicus, give it a 1. So I don't think anyone will put a 1. No, I mean, just for, this could be even like a test run. I'm biasing, but I mean, this is for the people who don't know what Copernicus is. Copernicus. Yes, yes, start voting, start voting. I was just joking, but you know, it's that kind of answer. A 1, if you think that it is already operational. A 2, if it is something that we can develop in the next 5 years. A 3, if it is something that it will be really, it will take a long time, up to 10 years to do. So we have 21 people answering the questionnaire, and there is 16 people who have voted so far. Okay. So there is a little, so there are some people so very quick, some people taking their time. Okay? So here we can see that already most of the people think that it will be operational, but not immediately operational, that there is maybe some people who think maybe in the medium term, but the majority of respondents think that it will take at least 10 years. Okay? Right? So this is first result. Okay, so now I think the other ones will come a bit easier because now with the mechanic. Fine, all the fingers, very good. I don't know what is this. I don't know what is this.
For the first question, we have 2 votes from Laura and Chuanmin. So Chuanmin was voting 1, and Laura said, I would vote 2 with caveats. Just reporting.
Chuanmin was voting 1?
Yes.
Why?
That's what I don't know, that's what he writes in the chat. Chuanmin, if you can...
Just, Chuanmin, if you're listening, this question is about detecting the plastic. Just to make sure. It's okay, it's okay. Okay, so the second question was about relevance. So in this question, we're asking, or the question is, as it is written in the paper, it is, we give it a 1, so a very high score, if we know who the users are, who would take a product of a plastic floating litter. For instance, it is an indicator of SDG, or it is not. Would it be uptaken immediately by the United Nations if we had it tomorrow? If you say, I'm going to the United Nations, I would take this. So you can, that would be a 1, and a 3 would be, but we don't know who. We're doing this just because we have a lot of spare time, and we don't know who would take this. We have to do enough effort to identify who would take this. So you can start voting. I don't need to say. So you can start voting if everything is clear. In your presentation or something in your slide. I don't know. Xiaomin may explain. No, but the question is about, is it operational today?
There is a question from Laura. She says that it's a fundamental question. Who is the user? Do we have a list of potential users? I know some people have been working with communities, but who else? That would be a great outcome of the workshop. Okay. So, but
this,
just...
Yeah, this is, Laura, this is, as it is worded in the yes, that would be a great answer in the conference, but as it is worded to this score is whether we have with the plastic, floating plastic as a product on accumulation areas would be important for management questions, to inform CBD targets. I know that one of the CBD targets is marine litter, to inform SDG, Sustainable Development Goals, one of these, I think is 14.1.1, no, Shungu, you know? Fourth is to provide, so that kind of thing. I don't know who the users specifically would be, but there are already some possibilities to uptake. So here the result, it's the highest result is at 2. So can you take note of this? We can put it in the table of the slides that we have. Okay, so I'll move into the next one. Don't answer before I explain it. Just a kind reminder, because for the clickers. Okay. Feasibility. Now, the feasibility, it's well, the science community knows how to measure the remote sensing product at such a scale that the measurements can realistically be made and or observations already exist. And I haven't finished explaining. This indicates the so a 1, if you give it a 1, you're having a high maturity of the science, of the technology and the experience needed to make the remote sensing product. You don't need to do any development and research. That would be a 3. A 3 indicates that you would have to have a lot of development to develop, to do an algorithm that that would identify the plastic litter in a mixture of floating materials. This is different from the next question, which will be about uncertainty, so accuracy of the product. So this is just about whether we know the principles of the algorithms and we know the fundamental science question, no, and technology that we would need to do this distinction. And we know, no?
Yes.
You can expand
indeed,
on this.
We discussed
and now you can start.
last criteria together, because in some cases you can already know the instrument you need, you have already the algorithm available, but in fact there is still a lack, for example, of validation. For example, validation of data, of satellite data.
That would be in the next question.
Yeah. But
this is about the principle.
Mostly together. I mean, so that it is a good thing that you introduced both criteria.
Yeah. Okay. So there are some people who haven't still voted. So is this clear for everyone? If people have questions, you can also speak and say. It would be nice also maybe to hear a bit of justification who think you voted why you have voted this. For instance, I'm curious to understand why people are voting like a 2 for this. If someone has some views or to justify their vote. It is a safe space. It is you're streamlined in YouTube, but it is a safe space. That number 2 is very safe. Okay. All right. So I have 18 out of 22. If there is no more people, I'll move. So this, the highest will be at 2. Okay, can I move on? Yeah. So the last question that we have, it is about accuracy. So in this criteria, we're talking about accuracy. So it if you give it a 1, if you give it a 1, you're saying that a fully operational network or service is in place, generating the remote sensing products that are accurate for the purpose. So And a 3, it means that no or very limited action has been taken to generate accuracy of this product. So it is there is still quite a lot to do in terms of generating accurate products in terms of comparison with in situ data or validation. Okay. Any comments from the audience? Anyone who wants to say something about this? No? All good? Okay. Have we recorded all the 4 answers into this? Have you taken note of the 4 answers? So we got... I don't know if there is a recap. I would like to have a recap, but I am not sure that automatically. No, unfortunately it doesn't. So that's why I was asking.
Okay, so in any case, the first criterion was ranked, the votes were
so
for 3.
So the first criteria was the maturity, and the maturity was given a 3. So it is a complete lack of relevant infrastructure for implementation, like an operational, in an operational sense. So we had a 3.
Yes, the second criterion was set rank of 2.
The relevance. So we have a 3, a 2.
The feasibility 2.
3, 2, 2.
I mean, a large consensus, since there were 18 out of 20 people voting 2. And the last one
was the uncertainty character, a 3. So it was, read it again, it was a 2, no,
sorry.
3.
2, 2, 3.
Okay, now we can show what we discussed. It's not the correct answers, it's what we discussed. Okay, so here...
First validation exercise, so floating plastics. Well, we were a bit more generous.
Yes, with the...
Yes. Sorry, I was without the microphone. Sorry for this. Thank you very much. Well, we were definitely more generous with relevance.
With the relevance and with the maturity, I think. If we start from the first one, which is the maturity.
Maturity is 2 for us.
And did we get it right?
The audience was 3.
3. We were more. We can explain our 2 because we thought that if the science were developed, it would be a quick uptake. So it would probably take less than 10 years to make it operational if we had a proper algorithm in place. So we gave it a 2, which is a bit more positive than a 3 to make it operational. We think that we have systems in place to make operationalization of algorithms quick. So that was the rationale between the 2.
In fact, the difference was that rank 2 was linked to being operational within 5 years, more or less, while 3 was operational within 10 years. So it is more a time-related, let me say, assessment. The second...
Is a comment, I've seen a comment from...
Oh, yes. I wonder if the fact that the chairs were more generous means a gap in knowing the status of maturity or what is available. This is an interesting result that may point to a need to better communicate what is available and what the status of operability is. Yes, of course, there is a difference between a subset of people assessing this, ranking the maturity of this product with respect to the audience, but in fact, it is mainly related to the time needed to achieve maturity, because as I said before, I mean that ranking it too means that people were confident to be able to achieve operational maturity in within 5 years, while ranking it 3 means that you will achieve the goal within 10 years. So in fact, this question maybe is a bit tricky, because it depends on several hypotheses. For example, is there will be funding for research and development in this field or not? I mean, it depends on a lot on this.
So in that
so.
we were more generous, in the sense that in the positive world, in the ideal world, that we would get quite, I mean, and then it is connected to the feasibility score a little bit. So this, perhaps the question from Laura is a sense connected to the TRL. So for us, it was, we would be able to make it operational if we had it, if we had all the research done. It wouldn't take 10 years to make it operational. We don't think that it would take 10 years, but that was the reason for the score. So if we move to the relevance, where we also gave it a more generous score, a more positive score than the people in the audience. So you can...
Yes, I mean, the audience ranked it 2, while we ranked the relevance as 1, because in fact there are already clear policies about this. I mean, plastics in ocean, there are still numbers, quantities. This is fully addressed in regulations, United Nations regulations. So in our opinion, policy relevance for policymakers is really high. I mean, if tomorrow we could say, well, we can measure how much plastics there is in accumulation zones in a marine environment, if we could provide these data operationally, I mean, in an operational way, it would be of great relevance for policymakers.
It is worth comparing our score of 1 here for the floating plastic accumulation, compared with the other one for floating matter in accumulation zones, which is more general. That is not explicitly part of any indicators in the United Nations SDGs or anything. So what you really, really want is the plastic concentration. So here we score very high. If you're able to detect it, you'll be very high. So if we move to the next one, and here there is, the disagreement is probably the more.
Feasibility. Well, by the way, we just to recall the meaning, we also indicated TRL, technological readiness level. We are quite familiar with this acronym. Well, we assessed it as 3, taking into account the maturity level of both instrumentation and algorithms to identify plastics in accumulation zones. So still also Victor always were underline plastics. Also from the presentation of this workshop, our feeling, as we already stated, was that there is still some effort to be done to identify plastics in accumulation zone. At the end, we thought that we need both a technological advancement, both in terms of instrumentation and algorithms. So we assigned 3. The audience instead assigned 2. So in this case, we were less, optimistic, if not a bit skeptical about the present state of the art. The last one, accuracy.
The last one is about validation of the products and the uncertainties that we have. And there we also thought that it is that we've been hearing a lot about how hard it is to get validation points in situ and how much it is needed. So a significant effort needs to be done in that direction. So therefore, we thought that there is a 3, so it's the lowest score there. And what did we get from the audience?
3. We agree on it.
Fantastic. Is this the only thing we agree with the public?
More or less.
Didn't pass the mark here. 25% success on this. Anyway.
The size of the sample matters.
Yes. Well, that it was a validation exercise, so we had this. I think we can move on into the rest of the presentation. And but I thought it was a useful and interesting thing to go through.
Really indeed, really interesting experiments. So thank you to the audience and to Victor to make it lively. And well, any further comments on these results? Is there anybody that likes to add notes? Otherwise, we can proceed because we didn't stop with these, but we tried to. Oh, sorry. You are right. I'm really sorry. I cannot go back. Can you please? There is a problem with the. Okay. So sorry, I got distracted. Well, as you can see, we address several different products scenarios. First of all, plastics on beaches, as already said, as maybe the most easily reachable within a short time. With a medium rank for maturity. We thought to assign 1 to relevance because we immediately thought about town agency, environmental agency, marine agency, control monitoring agency, and so on. I mean, it is, of course, of relevance, especially for countries that have a lot of tourism and so on. Feasibility is maybe together with floating matter in accumulation zone, the one with the highest rank. Here there is a lot of work already done, published, and validated to a certain extent. Here, as for validation, rank was set to 2. We wanted to underline in the notes that this was demonstrated with commercial satellites, specifically WorldView, and this can be a barrier because of course, it is an expensive way to make it operational. Concerning floating plastics in accumulation zone, we have already talked a lot about it. Floating matter in accumulation zone without distinguish between plastics and other types of debris. It is as floating plastics more or less as for maturity. Relevance, definitely, it is definitely lower, while as for feasibility, it is definitely assigned to a high TRL. We have seen already several works, several studies on it. There are published papers and so on. Nonetheless, there is a lot of work to be done concerning validation. This also was pointed out during this workshop. Validation is a major issue. Floating matters in rivers, maturity very low. There is a high rank for relevance, feasibility still low, and accuracy, so validation low as well. I'd say that addressing accuracy is one of the major issue that stands out also from this table. So now we can switch to the next one. I think that you think so. Okay, fine. So these are more or less the next steps to be propositive, to try to proceed forward that we identified. First of all, we suggested a methodology, I mean a stepwise increase in the complexity of the issue that we are addressing. So for example, since we thought that presently we are more or less at detecting floating matter, maybe the first step could be separate non-chlorophyll containing floating matter from chlorophyll containing floating matter. And this is a quite reachable goal, was assessed as a reachable goal within a reasonable time, because it is also relevant the time parameter, especially if you talk about policymakers, impacting on policymakers. And then, of course, under this respect, it is important to enhance mixing techniques. And also simulation exercise can help a lot. So it is still something related to this first point. Secondly, we identified some issues that need to be addressed, like biofouling and also aging of plastics, because they have not yet much investigated, maybe. Third, defining effective procedures. This is also related to the time constraint to achieve something that is still relevant for policymakers and so on. For example, a suggestion was the generation of possible accumulation maps that can be used then to address more precise in situ sampling. We have seen that detecting from satellite floating matters, it is something reachable in a reasonable time. Related to this point, there is as well data integration from different techniques. This can help a lot in discriminating plastics from other type of debris, floating debris, and joint experiments, campaigns. This is strictly related to validation and, of course, increasing accuracy, the assessment of the accuracy of the measurements we have done. So I finished. I really thank you a lot, all the people that took part in this breakout session. Everything was possible thanks to their inputs, suggestions, comments, and so on. So a big thank to all the participants and to the audience that validated our estimates. Okay, so is there any other question, comment? No? No. So I'll switch now to breakout session number.
So you just tell me which one. Okay. Just 1 second, I'm checking if I'm sharing the screen.
Okay, hopefully this is supposed to work, I guess. No. Ah, no, okay. Okay, so let's go to, we are not following exactly the same order that we got, as you can see, so we are improvising on it. Nevertheless, I think it has been great to have the opportunity to get all these breakout sessions. What I'm going to present is the summary of the discussion points that we got in terms of the new proxies and processes, which I think was quite useful. We have a lot of discussion. And one thing that Shungu insisted I was putting in this presentation was this part of my today's presentation. He mentioned that it was important to highlight this cautionary message that we have heard a few times during this workshop. So the detection of floating or something at the sea surface is really not very difficult to do. And actually, the example of all these indexes being able to do that. But identification is the real challenge. So I think this is a very important message for future research work, and also to try to align expectations of the community with the message we send them. Okay, so I think it's very important to have some critical view on our results and trying to make sure that we report them accordingly to what we think that is the scientific value that they really have, and try to avoid entering in complex discussions which not always are strictly to the reality of the data. So thank you, Shungu, for suggesting this. And I'm going to, if this decides, please next. Yeah, this is not working much. So in terms of the conclusions, after the so fun interactive presentation from Victor and Valentina, you are going to get a very boring text-based presentation from my side. But okay, we will try to make it in more interactions. Perhaps if people want to express some comments or something, you just raise your hand and we can try to interact. The same for you guys, so let's make it more dynamic perhaps. But one of the first points that we discussed and we concluded is that proxies are acknowledged currently as the best opportunity we have from satellite remote sensing for provision of information on marine litter and debris. So this is, from the point of view of the group that we were discussing in these topics, what we agreed was probably the most likely target that we can currently work on in order to get more immediate results in the short term. So it's very good that we introduced the technologies stages before, because maturity level also, it changes a lot depending on what you want to do, right? So proxies, even though they have some other issues, as we discussed, what's the connection with the users, this one, at least from the perspective of understanding better processes, are very good at. So maybe not yet good for, let's say, a user community, but very good from the scientific point of view to make a deeper understanding of the dynamics in the ocean that are relevant for this and the circumstances, as we will see later, that are important to have into account for monitoring marine debris. Several parameters can be used. So one of the questions is what type of proxies we could use for marine debris, and we identified some. Mainly, these are based in suggestions coming out from literature and opinions from the group, but we were discussing about total suspended matter and chlorophyll A. Those mainly are helpful to infer the presence of micro and macro plastics, including, of course, the fronts and floating matters, which has been also thoroughly discussed during the workshop. But it is true that for microplastics, there are already some good works in total suspended matter and chlorophyll A that are worth to perhaps continue exploring. And so we saw also some presentations. There's a poster, I believe, in terms of the use of surfactants, for example, which is another proxy, right? We also mentioned that there is a lack of validation verification data. This has also been one of the outcomes of the first topic that we have discussed. So work on the field is required to better understand the range of validity of the proxies and how they can be used. Validation campaigns must be planned and executed, and this is important. And we heard today from Giuseppe, very nice presentation on how those campaigns can actually support work in Earth observation. But usually this type of things require more global efforts. Obviously, he proposed to do something. He's already launched the idea to try to repeat something like this in the Adriatic Sea. But this is just one case, one example of the entire ecosystems of environments and places that we should be able to try to introduce. So I think it's important as a message for the community to widen the efforts in this type of activities, engage more in the networking of the in situ community to try to combine them to do further activities that can support the development of Earth observation and help us to understand better what we are observing with satellites. We depend on that. Otherwise, it will be very difficult to mature the technology. Again, I continue, but if anybody wants to say something or any of you guys want to add something, please feel free. Yeah, I don't want to saturate it. Also, my voice is like very serious monotonous, so people can sleep well. So it's helpful to hear some other voices. Ciao, Victor. We also concluded that distinguishing plastics from spectrally similar non-plastic materials is a challenge. Further work is required to reduce the presence of false positives and improve the quality of proxies, especially in the detection of floating matter. So yeah, this has been one of the big questions throughout these 3 days. No? How can you really make sure that you can separate false positives from true positives, and part of the work that is still pending goes in these directions. And then the slide that Shungu insisted to put on the table is again relevant. It's getting something that works in your algorithm, in your index. It doesn't make it automatically true just because of you use some plastic information, for instance, to derive your index. You need to be careful with this because there are other substances that can introduce false signals, and those needs to be taken into account. Another one which I really like also this point that Dimitri raised is a suitable revisiting time is important to better understand the processes linked to the littering effects and how events evolve. There is a good link between proxies and sub-mesoscale ocean scales, sorry for that. That should not be underestimated as a research opportunity. So this point has two versions, two orientations, let's say this way. One is that revisiting time is very important to link sources with the detections, or the other way around. We will do detections, eventually we will question what are the sources generating those detections. So getting a good timing of satellite acquisition is quite important in order to do this traceability between detections and sources. Even if we are using a proxy, it still is something that you have to take into account. And the presentation from Dimitri with never shown results, because unfortunately he got this issue with the slides, but we had later on the opportunity to check in the results. It was very, very nice to see how the high resolution sensors were being able to tell you a bit the story of what happened with the littering event that they were monitoring. Another part of that is the thing, and Andres insists quite a lot on this, is that those proxies are not just interesting for the marine litter specifically activities, but also to better understand ecology and oceanographic processes. And I think it's also a good idea that we also try to put in value these works for other areas. So this links with the need to do interdisciplinary work. So for instance, going back to the maturity level matrices we just see, we are perhaps not yet getting a good understanding by parts of the policy makers and public organizations about what is the relevance of monitoring floating matter. Well, interdisciplinarity is a way to show them why it matters. I mean, if you can tell them, okay, these accumulations are likely indicators of plastic pollution and can be driving exposure to potential harmful ingestion or interaction with plastics and other materials, and this is very relevant for the ecology, for biodiversity, for other aspects, then you may have a way to land the message that monitoring those is important, not just for plastic pollution, but for other things. Other point was that the sources of detection and uncertainty due to environmental conditions and observing geometry are important. For example, sun glint and clouds. More work is required towards their identification and handling. I like a lot this bullet point, and some of you already start to know me, so I'm not the guy that don't say what I think. So I'm going to say what I think. And it's that we should also be careful when we check and publish content that are based in a sub-selection of carefully curated images, because there is a huge distance from doing some lab analysis with 2 or 3 images to get some nice results that you can publish and create an automatic processing system. And I have been working a lot in automatic processing systems for the European Space Agency. And quite often, these things that are kind of conditions that can damage your data and make it not useful are very easy to detect when you manually inspect one image, but are very difficult to handle when you have to automatically process thousands or hundreds of thousands of images. So in order to facilitate automation, the studies should also go forward. How can we handle these issues that are actually creating false detections or that can create problems and are not easy always to cope with them when you try to just get one paper and put it into a machine to chunk data on it. Yeah? The other point is linking detections with known sources, so local knowledge. And again, this is one of the things I also like a lot, is we have been discussing a lot during the workshop, and we had also good opportunities during the breakout session to discuss on this. It's like the local knowledge is very helpful to reduce uncertainties on our observations. So by reducing uncertainties, we are not meaning proper validation metrics. It's also something that we need to be aware of, but to reduce the uncertainty about how can we interpret the data that we get out. So if we get regions where we know that there is inflows of floating matter that contains marine litter, those regions are very good to work with them and see what can we do with the satellites and improve our methods, as well as to put in value what that information potentially for the regional population that can be affected by those events. No? So maybe it's hard to get a universal algorithm that will work everywhere, but maybe locally or regionally we can do much better if we understand the specific conditions and casuistics that are driving the pollution into those regions. And in the first block, just to finish, in terms of modeling, proxies can help to understand frequency of occurrence. Most sources of litter pollution are intermittent, an aspect not currently well addressed by models. So this is also something important. So we also got discussions during the session on how models have very different results between them because of currently they don't have much information to be constrained with. And part of that could be cope with the use of proxies, at least to better understand how the input dynamics. So most of those Lagrangian models, as you know, you need to disseminate your floating particles on it, and how you do it. Each team follows a given criteria, and that yields different results. But however, this can be driven by observations, both in time and in space, if we manage to give them data that can have a reasonable correlation between sources and the observations that we are providing. Again, anybody wants to comment something before we move to the next slide? Yeah, Kostas?
Okay, thank you. I have to say that I agree with all these bullets. I fully agree that all are very relevant. I want to point out, I want to stay in two of them. The first one is the fourth bullet talking about the non-plastics. As I said in my presentation, for me it's very important to understand that we are not in a binary problem, 0, 1, but we have to think that now there is another input to the categorization of the floating materials. So we can start again saying, okay, we know the spectral signatures or how the phenomena can be seen in satellite imagery when they float, and we have to add also the plastics. If we see this problem as a multi-class problem on the sea surface using several spectral signatures, I think that we'll continue solving this problem. Otherwise, we are in a dead end. There's no opportunity to really distinguish the plastics from all other material. This exists for both the classical methodologies of classification, those that we already known, and the new ones, the AI classifications. So we need to import our knowledge from the floating material that we had already, fronds, chlorophyll, high chlorophyll concentration, algae blooms, oil spills, everything that exists on the sea surface, and then add the plastics on top. And the second one that I want to say is that I fully agree that we don't have to generate the observations that we make in a very controlled environment. I consider myself one of those that they do control environments. And I have to say to the community that every time that we try to generate what we see in the control environment, we fail. Actually, we don't fail, but we find that it's not working. So every time we try to answer different questions, but in the end, when we try to build a model for the local area that we're working with, most of the times it's not working. So yes, in the control environment, it's very good in order to derive information, to understand the problem, to increase the knowledge that we have, etc. But it's very difficult to generate this information in a real environment. Yeah, so I hope that I added something.
Thank you. Anybody wants to add something from this first block of things? Or you are in love of my documentary voice and okay. Okay, so let's continue. So please, next slide. No, yeah, you want to say something?
Okay, so I will take the floor, going to the fourth subgroup. Okay, I'm... I have more slides, sorry.
Yeah, you know, I'm so boring that he was just jumping over me, you know, it's like a, yeah. No worries, I have the same problem at home. So, okay. Next slide, please. You changed it already, yeah. Yeah, so continuing with the modeling effort is needed. Models can be used to run experiments. So we just mentioned before, like models have issues because of it's very difficult to constrain their solutions if you don't have enough direct observations to constrain those solutions. So they can have large disagreements between them. And actually, some in the session mentioned the need to repeat the work that Eric Van Seville did in 2015, comparing the models from Lebreton, Maximenko, and I always forget which is the third one, but okay, there were 3 models that were intercompared, and Eric found out that there were differences between them of the order of two orders of magnitude, actually. So, and we don't think we have improved much on that. But it would be good to try again this type of experiments to see how we are in the modeling. But nevertheless, although models cannot be yet used for forecasting because of those discrepancies between them, they can help to represent processes. And this is an important aspect. I mean, one of the things that proxies can do is to help us to understand how behaves marine litter in the environment. And this by itself is good, but of course, if you don't have enough observations, as we said before, quite often we don't have the revisit time that would be ideal to really to monitor these processes in, let's say, at the reasonable time scales this phenomena occur. Then modeling can really help to fill this gap, and we can play a lot with models. It's one of the things that they have as an advantage. It's a quite flexible and customizable tool. So we should probably do more effort in modeling to better understand what is the value of our proxies and what they tell us about processes. The next point is the environmental drivers are important to understand dynamics and the links between the proxies and the sources. Aspects such as wind and sea state impact the detection capabilities and affect some of the proxies, such as a floating matter accumulations. Consideration to those are relevant to understand proxies and estimations made out of them. So again, there are factors, external factors. We just mentioned two, probably there are more, like wind and sea state, that they are impacting the capability to have, let's say, to put an example, floating accumulations. And the fact that we don't see an accumulation is not meaning that we don't have litter, and this is also an important message. We focus in those because they are easier to detect. So understanding under what conditions accumulations can appear or disappear is very relevant to correct maps and information that we are getting out of systematic analysis of data. And you need to take into account this variability, which is external to the inputs that we are actually getting, is more related to environmental drivers that are doing this effort of forming or destroying the accumulations that we can see. If you don't factor this into your results, then your estimations will be wrong. So it's something that is worth also further exploring. Regional information can be used to improve the validity of the proxies. Some of the look-alike substances have spatial and or temporal local patterns that can be introduced to remove false detections. Yeah, I saw something, yeah?
Yes, there is a comment from Laura.
Yeah.
What constitutes proper litter data for a model?
Well, this is a good question. If you ask me, I think proper litter model and what modelers will want, but maybe someone in the room can answer that question better than I do. Yeah.
Gridded data in mass conservation, in mass concentration units.
Okay, very specific. Thank you. Did you hear that?
Start to resolution we can provide, and after that go to mesoscale. About 10 kilometers is very good because our models now in the Mediterranean Sea have the resolution 6.5 kilometers.
Great. Thanks, Laura, for the question. Can you hear me? Can you hear me? Yeah. Okay. Sorry. Okay. So again, anybody else wants to add something in this question from Laura in modeling? Yeah. So I think we can read it. No, but I can read it. That's super important because the observations are very different, are at very different spatial scales. Yeah, of course. And this is good because this links also with the comment that we said before. Andres put a lot of effort in trying to showcase the different spatial scales that are related to the detections. And it's good to put this into context, especially when we try to plug it into models, no? Right? So models most of the time cannot cope with 10-meter pixels detections because of the resolution they use is much coarser than that. So how you transfer that detections at so small scales to something that models can use is, I think, is a good exercise or would be something to think about. It's a good point. We were also mentioning before about the regional information, and this comes out to the fact that some of the lookalike substances that can be confused are actually having a specific behavior. So, for instance, they appear in particular seasons of the year, or they appear in specific locations. So, I think Laura is saying something else. Yes. As an outcome of the workshop, could we have those constraints, needs for models documented? Yeah, sure. I think I totally agree. It's something useful for the roadmap. Yep. So, as I was saying, then the local knowledge can help you to try to filter out those potential false detections if you know that those materials are happening in particular times and locations. This is also goes for the overall, again? Yeah, works, okay, yeah. Those are also good for the cases in which we want to constrain admixing, because one of the things that you have to do in admixing is to have, as I showed before, some prior information of what you could expect to be present. So local knowledge, it helps you in taking these type of decisions. And talking about that, we also mentioned about that it could be good to identify specific regions that can act as benchmarking sites. Field campaigns can be consistently carried out in them. So this was a proposal in the sense of trying to put a special effort in identifying locations around the world that could be optimal for, let's say, act as laboratories that could be also monitored by institutions or organizations that are nearby, and that they can provide more or less reliable information in regular basis. Those places could be great actually for testing algorithms and to do the validation exercises we have been discussing. So I think it's a good idea if the community can propose sites that they feel is of interest, and in order to try to see what can be done to prepare observing systems in those areas, which will be much more affordable than just going into the global scheme.
Sorry, can
Yep.
I just add on that?
Sure.
Just an idea. I mean, we have some places also in Europe where you have time series stations where a lot of data are being collected since many years. So since there are regular monitoring in those stations, that would be an ideal spot for have a constant, like, you know, every time there's a ship going and sampling in that area, then you know that somebody might be looking from remote sensing on those. And then you have all the other parameters and also historical data in a lot of stations. So that would be just an idea.
Yeah. That was the logic actually behind this, and of course also try to get locations that are representative of the main scenarios that we could consider in terms of the plastic pollution. No, at the end you need to try to make it representative if you are going to just select some points. No, but yeah, it's actually it's a very good comment. Anybody else wants to comment further on this? No. Okay. Other aspect that is also critical is the free access or fair conventions, findable, accessible, interoperable, and reproducible in order to get access to the data and the distribution of the data set. So one of the things that is very insisted quite often is to make sure that the global community can access to the information that is relevant for the development. So this is very important to access to the validation data and also to the spectral information or reference of end members, which is crucial. We have discussed this in the workshop that we had in ISA in October 2023, but it's still relevant. Getting access to spectral information and validation data is very important if we want to do progress. So further effort needs to be done both in collecting this data and both in putting it in places that is accessible to the community rather than scattered all around. Another point is the collection of spectral references with some standards, and as a community, efforts should be done of the priorities in the roadmap. References are of essence to continuously progress on satellite remote sensing of marine litter. So we heard the other day from Laura that NASA is doing an effort in this direction in trying to collect all these spectral references. Obviously, some people are concerned about getting data sets from different places that have been measured with different, let's say, strategies, which is not always making them entirely compatible. This is something that probably should be part of also of the discussion in the future. No? And actually, just to put an example of the relevance of this in the Horizon program, in the new calls, there is also comments on the scope of the activities that harmonization is still very important. And I will extend that harmonization is not just about the information of plastic litter, but we also should do that in terms of the spectral information that we use for the references. There is also a comment on terms of that marine litter composition is varying on time, and it could be good to revisit composition to adapt to the new situations in terms of material. So someone in our group mentioned this, and I think it's also a good point. We have been showing spectral references based in the knowledge that we had of the materials that are present within the marine litter. But many of those references have been built with information that we had at the time. So some of them have already some years of time behind us. And the reality of the marine litter is not static. It changes according to the consumption habits, and it changes according to regulations. So we cannot assume that the references that we are collecting now will be representative in 10 years' time or 20 years' time. We should continuously monitor what it is coming anew or what is changing in terms of the composition of the marine litter that we should consider in our work. Before we go to the last slide, any further comments? Someone wants to add something on this? Panelists? No? Okay, so let's go to the other slide. Yeah.
What is stopping us to get these spectral data sets? Like, I mean, in situ labs also probably are available also, but I think we want from the field, no? From the satellite. Is it like
we are talking more about fiduciary measurements, so something that you can use as a member.
But like from satellites, so the spectral signature of a given floating matter?
My personal opinion is that you cannot get fiduciary estimations from satellites at this point for this type of issues. We should go more into the field and lab for measurements. So for instance, Shungu has been involved in production of a few spectral libraries of materials, and Vito has been also doing it, and more people. So we have, let's say, a bunch of hyperspectral measurements with a wide spectral range that can be used for the data, and there have been other studies in the past that have produced data for other floating materials that we also can use. But this goes in the line of trying to get spectral observations that actually you really trust what they are, and therefore you can use them as reference to cross your information to do your own mixing. Yeah. So Laura has raised the hand. Yeah. So Laura, maybe you want to speak yourself? Yeah, yeah. Thank you, Laura. I fully agree, actually. And also something that I think should be part of it is to survey the requirements for those libraries out of the community, because of not everybody has the same needs in terms of their references, including spectral ranges or spectral resolution. So I think this is also something that should be part of the process, to collect those, to make sure that they are representative so that they can last on time for the community, according to the foreseen uses that we will do with the data. Any further comments on this? Anybody wants to highlight something? No? Sure. Yeah, yeah. So we have some people here working with drones. So what do you think? Sorry.
Yes, hello. In terms of drones, I think that we can have very good spectral signatures, especially when we do have them on the field, on the real situation. So we can derive spectral signatures, and we can see the difference with biofueling and with some water content, because as we know, in SWIR bands, we have a lot of dispersion of the signal due to the absorption of the water in these wave bands. So yes, in drones the situation is quite nice, and we can derive many good information. However, we don't have the atmosphere there. So atmospheric correction doesn't really exist, and this somehow has to be involved when we will generate this information for the satellites. Up to now, in the PLP, we don't have hyperspectral measurements. This is because our hyperspectral section is a push-broom system, and this push-broom system is not really good for spectral signatures due to the ways that the targets are moving and the sea is moving, so we have to do it with global shutter. The data, the targets will be there, so anyone that want to come and use them and create signatures, we're very, very happy to join on the project.
Yeah, thanks, Kostas. But yes, I agree also that having this consideration for the drones is obviously relevant. It's a very good intermediate between satellites and targets.
Actually, with the multispectral that we have seen the comparison, it's really impressive to see how close we are, especially with Sentinel-2 and with the very large data set that we have created. It is quite obvious that we can see the same things with drones and with the satellites. However, we have to think that our targets are based on a white net, which is very easy to be seen, and there are not many variations on different colors, etc. From the other side, when we see this white net after biofouling, it's a bit nice to see this brown color, and to see how the spectral is changing during the time. Again, the change of the signal due to the water content is very important. So we have to face three let's say, big parameters: color, biofouling, and water content.
Okay. Anyone wants to comment something else on the spectral libraries? Yeah, it's one of the hot topics always that we mention it.
Okay, I forgot something, that it's very nice to have drone data for unmixing algorithms in satellites.
Yeah.
Once you have the drone data, you know exactly the endpoints, so you can use them in order to simulate the end members that you need for the satellite imagery. And this works very nicely. We can do it, and we can do really good experiments with several materials that exist on the sea surface, not only plastic or wood, but whatever we want to put there. So yeah, in terms of simulation and experiments, we have the knowledge now to create any type of target that can be used for calibration validation in satellite imagery. And have in mind that we also have different sea states differences, which is also important when you want to generate information in a different environment.
Okay, thank you. So yeah, let's move to the next slide. I think we should go a bit quicker so we have more time for the others. The third point, the third slide, we mentioned also that given that windrows are the best proxy we have for plastic pollution, further work should be done to investigate their ecological relevance and potential links with exposure of marine organisms to this form of pollution. Well, we just mentioned that, or I just pinpointed this before. More work is required in radiative transfer so as to better understand the observed signals from satellites. In terms of use of proxies, more work has to be done to derive statistical data, for example, trends or hotspots. So again, here this is a point with two sides of it. One is related to really understand what satellites are observing in a better manner, so we can really go deeper in how to use satellites to monitor what we want to observe. But the other thing has to do with the fact that, again, it's one of the things that makes proxies good is you accumulate a lot of data, and then you start to do a statistical work on that data. So this it has to also be done, trying to gather or exploit better those proxies, and then trying to get more into the data that we are getting to see how those trends and hotspots can be correlated to what we know of the plastic and litter pollution in general. It is important to work on the construction of indicators tailored to the needs of policymakers and monitoring organizations so as to bring the possibilities of remote sensing of marine litter into the national monitoring plans of agencies and public organizations. This, again, in the previous topic, we already discussed a bit on this. But yeah, the part of the things that we see is that there is need to make sure that there are indicators based on the remote sensing data, so that there is a need for that observation that it is embedded into the public agencies that are responsible for monitoring plastic pollution, which is not always the case. We know some of the indicators from the UNEP in SDG, but they are, for instance, centered particularly into the pollution that happens in international waters. So that is not necessarily what policymakers working in specific countries they want to have. They probably want to know better what's going on in their own national waters. So it's important to make sure that we transfer indicators from remote sensing to those communities. Then last 2 points is that working with the marine ecosystem services could be a way to engage with the user community, and this could help to engage with funding activities to continue developing and implementing indicators based on proxies. We again mentioned about the multidisciplinarity and the relevance to make sure that what we generate, it doesn't remain as a scientific curiosity, and it becomes in some actionable data that can be used for something. And working with the marine ecosystem services can be the way forward to let's get your seal stamp into your data sets and into what we are doing, so that can be used. So I think it's an important point. And finally, also has been discussed previously, is that uncertainties are an important aspect of satellite detections that should be better considered. Further effort must be done in assessing the range of validity of candidate products. And this is quite important. Circumstantial validation is not enough in order to make sure that the information we are generating can be used. It's important that we are able to actually put error bars in what we are providing to the users so that they can actually consider how best make use of that information. This is a common requirement of Earth observation, and I think in our context, more effort needs to be done into the research producing assessment of the errors in the estimations. Those are all the points. I don't know if anybody wants to add something at this stage. No? Okay, so Costas?
Okay.
Yeah, sorry, before we change topic, I just want to thank you to all the people that have participated into the discussion. It has been very useful, quite energetic too sometimes. And I think we had a very good time, and I want also to take the chance to thank the organization for the opportunity to meet together, put all the facilities, our services, and all the work. Yeah, but I wanted to show that later, but okay, we can do it later perhaps. Yeah.
Just, if I can comment a bit to the proxies, I want to say that nowadays we have searched a lot, and we have done, let's say, in-deep research on the data that we have already available. Means that we have worked a lot with Sentinel-2 data, with SAR data, with high resolution data, with very high resolution data, and we have seen the ability of commercial imagery. I think that for going further, we need new toys. And new toys usually goes to new satellites or new sensors that they're dedicated with for maritime detection. Otherwise, I think that we are going in a direction that we will play with the toys that we already have. We know where to go to classify different phenomena on the sea surface, but without the proper technology, we cannot reach next technological level. So right now, we are in a position that we know what we need to go to the next level, and for that reason, I think that the space agencies should think about using their let's say knowledge on an experimental satellites or sensors, and give us the opportunity to go one step further. So no, it's not only about the proxies that we want to detect, but it's also the ability that we have in a technological progress. Okay. Okay.
No, I think it's a good point from Costas, because of when sometimes we forget things after so many years, no? But when we started, at least in Europe, the idea of remote sensing on barometer, the main questions that the European Space Agency made us is this feasible? That was the main question. Can we do actually something? And if not, tell me what I should perhaps do, or how can I help you to develop technologies? And we are trying to jump into direct exploitation of the data sets that we have, which is good. I think you should follow the two paths. You need to really exploit what you have and also develop technological roadmaps at the same time. But maybe we are pushing much in one of the legs and not so much in the other leg. And yeah, I think there is need to support further technological development. I agree with you. Yeah.
I think that first steps that have been done from Vito in this direction is very, very important for the scientific community in general. So it would be very nice if we can support this initiative and give any information that we need, etc. So yeah, I think also as a scientific community we can contribute a bit of what you're doing.
It's not for lack of trying. I can witness that.
Okay, thank you. So we move to the next breakout session. I think that I'm the only one not having slides. So I have two excuses for this. One is that I was thinking that we do have a panel discussion more than presentation, so it was not coming natural to me to create these slides. Sorry for that. And the second one is that in our group we had a very diverse very diverse people being with us in the table. So it was one part in remote sensing that we have to do with satellite data and probably drone data. I'm working with them, down to nanoplastics. So we have to somehow put everything together and come in a conclusion on how we can connect this information from satellites down to nanoplastics. And our topic was remote sensing of plastics in inland water bodies and coasts, including harmonization of low altitude monitoring. So I can stay a bit on the harmonization. We discussed a lot about the harmonization, and we found out that there is a huge issue on harmonization of different methodologies from satellites down to nanoplastics. Even in remote sensing, using different atmospheric correction algorithms, it's very, very different when we end up in some products. So as a scientific community, we believe that it would be very, very nice to have a roadmap and somehow to harmonize the methods that we are using for going to next steps. And I know that this is not very easy right now because we don't have the right path, let's say, for doing the detection, identification, classification in terms of plastic detection, but we should always think about the harmonization. Exactly the same thing exists on drones. We have a very good example there that we defined the spatial resolution that we need in order to do an algorithm that is working universally. And once we harmonize the data that we collect, it was quite easy to build an algorithm for doing the plastic detection on the shore. I believe that the same thing can be happened on the sea surface, and it's very important to understand that the different sensors that the drones carry, we can play with them in order to find a way to have always the same type of data. Also in terms of spatial resolution and on spectral information. So we need somehow to find guidelines and to have very basic information that we can use. Otherwise, if we go to the very, very specific wavelengths and very specific type of spatial resolution that we need, we cannot have a uniform solution. Exactly the same situation exists for nanoplastics and the microplastics. I'm not an expert, but the colleagues there explained to me that harmonization is a big issue. So always we have somehow to think the very basic information that we can derive from very simple methodologies. If we agree on the very simple methodologies and how we can derive this information, then I think that it will be much easier later on to find more complicated information that we need for our problem. Also during, also during our discussion, we had some questions that we had to answer, and these questions it was quite useful in order to have a discussion. And the first question was, what information is needed to help to close the plastic loop, which is to reduce the plastic leakage? And we had a very, very long discussion about this question. And Stefano Agliani helped us a lot in order to understand that it's not only the technical information that we need, how much plastic, where these plastics exist, how we can measure it, etc., but also to connect the plastic with social economic information. And we discussed a lot that there is always a connection of level of education in one area with the leakage of plastics in the other. So somehow the social economics factors have to be included into the bigger picture that we have on where we have to spot our attention in order to find very useful information for plastic detection. The second question that we had, it was what are the research questions that need to be prioritized to improve estimates of fluxes? And that is very, very, very generic question. We had a long discussion and sometimes went to a philosophical discussion. I have to say that the research questions are always important in the perspective of the basic education of each one of us. However, we came up to a conclusion that it's very important to understand that there is a different toxicity in the different type of plastics. So for us as humans, it's very important to understand that we have to find the toxicity that exists in the different areas and to focus there. Because, okay, we have seen all these images that they may affect some mammals, etc. But in the end, it's very important to know what is toxic and try to focus our information there because it's very harmful for us. And the third one, the third question was, can we estimate leakage from landfill variations? This is quite, I think, easy to be answered if we have the technological tools. In terms of satellite imagery, drones, LiDAR, etc., it's very, very easy to understand the leakage from landfills. But when this information goes to nanoplastics and to microplastics that exist on the air or in the water that comes out from the landfills, this is very, very difficult to be examined. So we need new technologies or new ways how to make these measurements and how to include those measurements to the big picture that we have with satellite data and drone data. So in the end, the low altitude, let's say the low altitude measurements that drones are doing are very, very useful in between satellites and the in situ measurements. We have seen that in many different situations and research, at least in the field that I'm working with in marine remote sensing, from seagrass mapping to plastic detection. It's very nice to have a ground truth. Then this ground truth can be generated with drone data, and then you have the satellite on top that can take a really large area and can reproduce the information that you want. So for me, drone data are we can see them as in situ measurements in a larger area. And this coverage in the larger area can be depicted. We can see it in satellite imagery, which is the case that we want to use. So I want to have an idea of using the drone data as something between the in situ measurements and the satellite imagery. Yeah, I think that was for our group. Sorry for not having a presentation, but also there are some people here that was present to the group, so if anyone wants to take the mic and say a few words, would be very, very nice. Okay.
Just to contribute a bit, I just want to do a comment because of, in terms of impacts, I think is very relevant. At the end, why remote sensing of marine litter is important, and I think that question should be always on the table, why we want to do it. And I think the impact in ecosystems is one of the main reasons. So I wonder also sometimes until what point we know really what's the impact, no? And I know there are many studies about how litter is affecting especially birds and fish, and there is one of the main things that causes a lot of impact are the ghost nets, that they really are harming large populations of different marine animals. But I'm not sure if we really have yet a good understanding of what should be what is the ecological or toxical impact of plastics in the environment, which could be very worrisome. So yeah, I think it's a very good area to continue working. We should know this.
Yes. So Laura is saying that the path to space is lengthy, and starting with what we have, what is possible and why it's important to be able to be immediately actionable. Given the spatial scales and distribution of debris and the size of planet Earth, space-based detection remains challenging. We agree that investments in new technology are important, but we as a community need to come to terms with needs and applications. Who need this information, how fast and what type. This will also help drive what platforms are best for remote sensing of marine litter and what instruments can be fitted in those platforms. Drones are very promising. Yes, I totally agree with Laura. It's exactly what she says it's important, what we need, and we always have to go hand by hand in order to have the scientific knowledge and the technological means to go further. So, yes. And also I want to reply to the previous comment that yes, usually the measurements that we have with drones, it's also connected with in situ measurements. We always try to have everything that exists, we can count on the field at that time. Wind, wave, temperature, composition, etc. And we try to correlate this information with satellite imagery. Always in a very controlled environment. Okay, so I think Sugu.
It makes my life easier. Okay. I'll give the summary of our breakout session, but I guess this also, like, I'll tell it as a story. So in case there's someone here who is interested in getting, like a big overview, but very simplified, we have a report which provides advances on remote sensing of plastic waste. So it's also available for download. Next slide, please. Again, well, it's just always nice to give people context why we have to do remote sensing. Of course, the lower measurements, like the field measurements, they provide us with invaluable information, but we go to satellite because at the end of the day, the cost per area unit is relatively lower. Of course, it's very expensive to launch a satellite, but over time and in terms of coverage, satellites are very useful. Next slide, please. One thing we also have to remember, this is a new field, and we are not only looking at optical tools, but we have this whole list of sensors. Here's just a summary, and we are also looking at different retrieval algorithms. But, next slide, please. One thing we have to be very clear, and well, some people have seen this so many times, but there are like 4 main applications, in my opinion: detection, identification, quantification, tracking. And if we can clearly state these capabilities from remote sensing, then it makes it easier to like deliver our message. So detection, that's quite easy, relatively simple, because you can also use RGB information, or you can do the extra work with multispectral sensors. But identification, separating the plastic from other material, at the moment, with the tools we have, we need shortwave infrared information, hyperspectral information to be very confident in what we are talking about. Again, going back to detection, you do not need so much waveband information. You can do detection of seeing if there's something on, yeah. Then you go to quantification, there are different metrics, but then again, depending on what the end user requires, what metric is useful to your applications. Either you're looking at pixel coverage, a percentage, it could be a number. That is quite simple because we have, let's say you're using Sentinel-2, you have a 10 by 10 pixel coverage, but this is, remember, this is surface coverage. We have to be also very careful when we provide metrics to people. We are looking at coverage that is only on the surface, but going down the 3D component that can be estimated from field observations. Then, of course, the tracking, that depends on the revisit. So that the point that was raised, how many times you're getting observations of your target material. Next slide, please. Again, this is also just an overview of like what we already know at the moment. So when it comes to abundance, when you go to smaller sizes, we don't really know much about that information. We have the limit at maybe up to like microplastics because we can do the sampling with nets. And then of course the mass, it's quite easy to know, but of course, depending on the size of the object. Environmental risk, you have the ingestion, the smaller they get, they are quite easy to ingest. The entanglement is also, the bigger it is, the easier it is to do it, entanglement. Then again, the last point, the main message here, you see the ease of remote sensing. How easy is it to do remote sensing of plastics? Well, not plastics, but floating material. It's quite easy if it's aggregated in windrows or artificial targets. This is part of the maturity, what we have seen in publications. Next slide, please. Reality of the scenario, I think almost everyone knows this. This is what we are discovering in nature. It's a combination of material. So do we go for remote sensing of plastic, or do we go for remote sensing of the whole patch? We have to be very clear. Again, that's the slide that was given by Manuel. Like the indices that are out there, well, they can do the job. That's quite easy to detect if there's something or not, but we are not separating it from plastic. Next slide, please. Well, you know, as a scientist, you also have to promote your work. But, sorry. No. But the main message here, what I'm trying to say is there are so many other resources. As much as we also are using Sentinel-2, there are other resources we should really also intensify, studies on. We have the opportunity of using PlanetScope, and PlanetScope, you get sub-daily information. SkySat, you can also, so here the main message here, I try to give you the example of saying you have an image at 8:57 and you have an image at 9:33, and with that you can do tracking. You can see like how things are moving within a short space of time, right? But, well, you don't know if it's plastic. That's where you need in situ observations. Similar scenario is also here. PlanetScope is being used within inland again. So next slide, please. Here, just to show like in different places, you can use all these different sensors, you get information. That is, you can do quantification, but that's surface coverage. We have to be very clear again about that. Can you go on next slide? So within Europe, I can also like, reiterate this, and of course NASA also has this service. We have access to even commercial resources. I think we should also consider using these resources because they are readily available to the community. So you have access to PlanetScope, SkySat, WorldView, Sentinel-2, and I think Laura, you have also have a list of other sensors you have access to for the community in the US, and I think Chuamin Hu also mentioned a few of them. Next slide, please. Here I'm also happy to say, again, going to different resources, this is open access data. We have Prisma and MAP, also from NASA, AMIT. Here I just try to demonstrate this is over land, but already we can look at plastic greenhouses. And from all these three sensors, you get very nice spectral signatures. So the next step is to look at patches in the water system. Of course, that's something to be explored. Please feel free to do that. That would be nice to get results from the water system if we have plastics, and also demonstrate that the actual missions we already have out in space, they are very useful for these applications. How useful? That's to be, that's to be discovered, yeah, confirmed. Next slide, please. Well, yeah, it's just an example to show like from the different three missions, vegetation already like just an example. Looking at a target like vegetation, you see the spectral signatures. They look very nice. They are consistent. And one thing I have to mention is, well, there are people who are working on delivering analysis-ready data, which is like they are level 2 products, and they are consistent. They show the same information. Spectral signatures are consistent. So, well, good job to all the different agencies, like from colleagues from DLR, NMAP, and of course from Italian Space Agency, and also from NASA. They're doing an excellent job. Next slide, please. Again, for plastics, this is just to confirm the information you're getting is consistent. And in this study, you know, like I also try to highlight, we have a drone image that was collected. We also did lab measurements. And from satellite, the information we're getting is more or less consistent. Next slide, please. Well, it's just here, it's just demonstrating the mapping that you can do of the greenhouses in one of the areas. Next slide, please. Again, we also have resources, so I always try to market the resources and work we have done. There's, if you're interested in publications on the topic, please visit our website on the IOCCG task force. And then, of course, there are also data sets available for people to experiment on and do analysis. And then we also try to highlight where you can upload your data. So there are places where you can upload data. I guess the limits, of course, as far as I know, I think Zenodo has 20 gigabytes, and of course that there's always that limit of how much data you can upload in one go. Next slide, please. Well, I'm always happy to show off, like it's a it's a painting where that was done with actual plastics from the ocean. Can we go to the breakout? Well, if there are questions, please feel free to ask. Happy to answer. Yes. So for our breakout session, again, this is collaborative work, and I'm honored to have been the coordinator of this team. Again, so we discussed like the issues about data access. That's why I said I'm going to try to tell a story. That's why I had some. We have so many resources. Next slide, please. Thank you. The same message I've already passed on. We have a curated data set, which is MATLib. It's already available online. And again, the IOCCG task force, like the website, is a very good resource if you're interested in getting data to play around with, or to find ways to improve what has already been done. And the repositories, here's just an example of the few lists, but also available on the website. Next slide, please. Well, some of the main points that we had from our group, there is a need for round-robin activities to compare what we are doing. It could be algorithms or even how we are collecting data. So that also leads to harmonization. How do we harmonize everything? We have to do comparisons to see where we are doing things very good or we are missing. And then again, to develop tailored open access data sets for different communities. So for modelers, there was a point about like the grading issue. So what kind of data do they require if we are going to provide outputs in our models? And then, of course, there's always need for direct field observations. That's it's been said like so many times enough already. But there is need for diversity within the observations, looking at different parameters or looking at different targets, blooms, harmful algal blooms, pumice, sea snot, sargassum. Then we can also try to end up with very good end members in terms of spectral properties. Here we just provide also the link to the MATLib data set, which was curated. And then we highlight the important, well, this is very well done. Like Marida is a very relatively good curated labeled data set, but we need to improve. There's room for improvement. Like how do we improve? That will be field observations where we try to link the satellite observations to field observations. Then we have that extra confidence in what we are doing, even the machine learning approaches. Next slide, please. Well, this just linked to Marida, and of course, one thing you have to be very cautious when you use data sets. Some of them, there are parts where there's so much inference in terms of like what is actually in the observation. Without the direct observation, then you always have to be very cautious that there's inference in such data sets. Again, that goes back to the issue when we do drone surveys or ship surveys or even field observations, please try to document your observations as much as possible so that, you know, like, we can use them with higher confidence. Next slide, please. I don't know if there's anything else to say. It's repetition of things. We need traceability. If you document all your observations, there has to be some traceability, even in the use of indices. As much as possible, try to have some traceability to say either it's a direct observation or it's inference. Well, I think that's the main message. Comments, feedback? I don't think there's any there. Slide? No? No, that's the last slide. Ah, well, it's just, again, I repeat the point of like access to commercial satellites. The data is available. You can go through ESA third-party missions. It's a relatively short application, and I guess for NASA, that's the same story. You apply for the data, then you can access archive data or request for, how do I say, request for new observations. So comments, feedback? That's the last one. I'm hoping. Yes. Thank you. Comments, feedback, suggestions? Everyone is happy? Thank you. Have a good day.
Thanks, Sungo. Okay, there was a comment from Shamin saying the knowledge of locations of large quantity of plastic should be useful for environmental protection agencies if they want to remove them at sea. Yeah, okay. So it was a comment from the previous discussion. Anybody else wants to add something? Yeah.
Just a comment. I mean, I was, let me say, quite amazed as from 4 different topics and 4 different breakout sessions. At the end, there were some commonalities, I mean, some common points like validation, data, assessment of uncertainties, like availability of reference data. I mean, there are several aspects that are still in common, even if addressed by, let me say, slightly different communities.
Yes, I totally agree. We have to face a problem that is complicated, and when you cut it in pieces, always you have a different perspective of it. But in the end, we have to face something which is out there, and there are several and different perspectives that end up in one thing. And yeah, it should be like this, that issues exist, but we have to face them differently from different perspectives and then focus somewhere. So I agree.
Yeah, and I just want to comment also on this. We have been discussing during these days. As you know, we have a task force within the IOCCG, of which the coordinators, most of them were around of it. I think just Madeleine was missing. But we have, well, of course, some of the agencies representatives, but we have Laura. We were lucky to have Laura online, and we are very we are very grateful for her to spend time with us. Laura also launched the need to consolidate these discussions that we are getting out of the different workshops into something more, let's say, tangible that could be useful for the agencies to work with, but also for the community to know where we are standing on and what are the research priorities that we should address. So one of the things that was already mentioned for the SPARSE workshop, it was the possibility to get as an outcome white paper. So we took on the idea, and we think it's great. And we think we should try to consolidate all these efforts done in these last years in something that can really work as a milestone. So when we started with this a few years back, we already did some preliminary papers. We have the work from Maximenko in the IMDOS that he coordinated very well, and we got this paper that was also in the Ocean Ops 2019, which maybe some of you know this conference. If you don't know, you should. So I recommend you to check it, because those are very important to set the observing priorities for the ocean community. And the other thing was the paper also that was prepared, led by Victor as part of the ESA activity that we started in 2017, was also published in 2019, and that paper was more about the feasibility. So we were considering at that time what are the relevant scenarios, what actually can do something with satellites or drones or something. So at that time, 6-7 years ago, we knew much less than we know nowadays. So we think it's time to update all of this. And what we are proposing is to prepare this white paper starting now. We more or less have drafted this roadmap to execute it, so we would like to have a first draft by the end of September, probably. Due to the summertime, it's always a bit harder for people to work. With a full draft due to the end of November, with the idea of having the opportunity to present the paper into the IOCS 2025 meeting. Is one of the reasons why I insisting on you guys to participate. And we will use that meeting to present what, as a community, we have already decided is important, and trying to polish things, trying to make sure that we get any feedback from the community in what we are providing within the manuscript, and then probably submit after Christmas time, some point in January 2026. We think it's important to put dates, because all of us are very busy people, and if we don't get deadlines, nothing happens. So in order to prevent that, we have to self-impose some discipline and trying to make it sure. So as you know, you can just, if you want to participate, get in touch with any of the task force coordinators, Shungu, Vitor, Madeleine Cowell, myself, and or I just put my email, but you can just contact any of them. Then we will gather the people who are interested in an initial draft to be seen later on. We are not yet in that stage. We will have to think how to orchestrate this properly. But at this stage, if you are interested, just show interest, and we will try to make sure that your contributions are introduced in the text. And of course, yeah, I think that's what I wanted to say. I don't know if anybody wants to add anything else on this. Yeah. So yeah, thanks a lot for your time and patience, and especially because, you know, Friday is always bad days for workshops and conferences. People want to be at home for the weekend, so it's good that all of you could stay around longer and contribute to this, hearing us, which I think is not easy always. And yeah, thanks a lot.
Yeah, I think we can conclude the workshop. So thanks everybody again. Yeah, I think it was a nice 3 days gathering. So I'm really happy about that. So thanks again for coming.
Yeah, and I think we can especially give another round of applause for the people who actually organized this locally. Amadeo and Alessio, thank you very much for all the effort. And a very big thank you, Luisa. I brought a small flower for the huge effort. But it's taking some sun from Siena home. Okay, thank you, and thank you all the breakout session leaders and the keynotes that came and gave great talks. Thank you, and thanks to all of you for your input over the last 3 days.